Day one, we always ask, okay, give us the material, give us all the components, and then we can design something with this. With LTM, that wasn't available. But what we did is start as soon as possible, just making something as a reference. What is hard to imagine from scratch is what it feels like, if it makes sound, what it looks like.
Although we're in a similar field, terminology was not a stumbling block, but it was a great big hurdle that we had to get over at the beginning. I think at the beginning we were all talking about graphs and really heavy data stuff, whereas that's relatively alien for designers to be in day-to-day contact. So we actually want to know, what do those graphs mean? That big hurdle was a great learning curve, and actually it happened relatively early in the process, which is great because now everyone can talk freely and understand each other.
When I'm designing, I really need to get this hands-on understanding of the technology to learn what are the qualities. I can say that it's waterproof, it's thin, it's flexible, but what does that mean for my understanding of the technology? I'm hoping that we can get some early prototypes along the way that will also start to give designers this material understanding of the technology before it reaches the market.
Initially, the relationship between the designers and the material scientists, there's a certain amount of friction because designers are very used to dealing with uncertainty and illustrating things and having that fuzziness, whereas engineers are extremely uncomfortable with that. Initially in the project they were quite defensive and they thought that we were being deliberately contrary or obtuse, when really we were just trying to ask open questions. But I think a lot of the engineers and scientists will probably admit that they're certainly happy to embrace the way designers think, in the sort of lateral way that we think, where we try and think of a solution to a need rather than incrementally working away with technology to achieve that solution. We start with a need and work backwards.
I would say that it has been challenging, mainly because it was who goes first. In the beginning we would like to have input from the designers, that was the say of the material scientists, whereas the designers, we want to have input from the material scientists. At some point in the process it started to evolve and we got some real prototypes in our hands, so it helped us understand what this material can do.
I think one of my key takeaways was that normally as a designer you come up with a concept and you present it to a client and the client will tell you, no, it's not good or this is good. But now we are the decision makers ourselves, so sometimes we get a little bit lost on how do we make this decision to move forward. So we're learning that and we're getting more confident with what we do. But to start, LTM material was very vague. What is it? What does it do? And now I think we're getting a much better grasp of it.
Material is going to be smart. Everything is going to be smart. That brings lots of complexity with it. I think the biggest benefit is this safe way that we can think about smart materials. I think within this project we can really explore in a non-commercial way and very open way with the other partners what this actually means. So I think this is a great kind of experimentation ground for this.